All right, let's walk through the steps to find the limit of this function. You'll notice, first of all, that we have our value x is approaching 2. So the very first thing you always want to do when you start out with these is try to evaluate your variable at that given value. So because x is approaching 2, what we're going to do is we're going to replace x with 2 and then see where we get to at that point. All right, so in the denominator, we get 2 squared minus 2 minus 2. Now, a little bit of simplifying down. Underneath that radical, hopefully you notice we have 2 times 2 will be 4 plus 96 will be the square root of 100 minus 10. So the square root of 100 is going to be 10 minus 10. It's going to give us 0 for our numerator. For our denominator, we have 4 minus 2 minus 2. It's going to work out to be 0 for our denominator. But that's okay. We ended up with 0 over 0. What that tells us is we need to keep going. So I'm going to bring down another copy of this, and let's continue the process. The next thing I notice as I look at this is we have that square root in our numerator. So with the square root in the numerator, we're going to multiply both the numerator and denominator by what we refer to as the conjugate of the numerator. So what that means for us is you're going to have that same square root, 2x plus 96, numerator and denominator, and you're going to have that same 10 numerator and denominator, but because this was a subtraction, the conjugate means we're going to reverse the sign, so that's going to be an addition in between those two. All right, from here, what we want to do is take our time and multiply out the numerator, and we're also going to go ahead and do a little bit of factoring on our denominator. Now, because we got to 0 over 0 initially, what that's going to tell us is that we have a factor that's going to be important of x minus 2. It's always x minus whatever value made the function equal 0. Eventually, we want to find an x minus 2 as a factor in our numerator as well, but we're just not there yet. But being that we have one of our factors for our denominator, looking at that first denominator, the x squared minus x minus 2, our other factor is going to have an x, and I guess 1 times 2 makes that negative 2 at the end. Let's make it a positive 1. Hopefully not too bad on factoring that part. We'll bring along and not multiply out this square root of 2x plus 96 plus 10 in our denominator. It's just coming along for now. But we are going to go ahead and multiply out our numerator. So one at a time here, we're going to go 2x, the square root of 2x plus 96 multiplied by the square root of 2x plus 96. So that can be the square root of 2x plus 96 squared. Or remember that when we square a square root, those are inverse operations. So they're going to cancel each other out. And you're just going to be left with what was underneath. All right, next, let's go ahead and multiply the square root of 2x plus 96 is going to get multiplied by a positive 10. Try to write this out as we go. So plus, we'll leave the 10 on the outside, the square root of 2x plus 96 multiplied by that. Now let's move on to the negative 10. We need negative 10 multiplied by the first term, that square root. So minus 10 square root 2x plus 96. And then the negative 10 needs to be multiplied by the positive 10. So that'll make a minus 100 at the end. All right. So take your time. Don't get in a rush as you're doing any of that. Just make sure you get all the terms in the correct place. And now we'll work on simplifying. So taking a look at this, thinking about simplifying, you may notice that we're adding a 10 times the square root and subtracting a 10 times that same square root. So these are considered like radicals. Adding and subtracting the same thing, those are going to simplify down and basically cancel each other out. All right, moving on to the next line here. Let's think about what other simplifying can happen in our numerator. Well, we have the 2x, doesn't have any like terms, but we have positive 96 minus 100, which is going to get us to minus 4. right? 96 minus 100. So let's just bring that along. The entire denominator we're going to bring along as well. Try to highlight this x minus 2. Remember, that's the sticking point. That's what we want to eliminate and in order to be able to find this limit. Other than that, though, everything is just getting carried along in our denominator, not worrying about multiplying that out. Next, let's think about that numerator. The numerator, 2x minus 4, our end goal, remember, is to see another copy of x minus 2 in our numerator as a factor. So let's go ahead and factor out a common factor. Both 2x and the 4 have a 2 in common. So if we pull out that common factor, and I'm going to go ahead and say that is replacing the 2x minus 4. So now we have an x minus 2 multiplied by our entire numerator and an x minus 2 multiplied by our entire denominator. We can go ahead and reduce this to lowest terms by canceling those out. All right, x minus 2 over x minus 2 means 1. And because we're taking a limit, that's not going to affect our problem. We're allowed to do that. All right, so what remains in our numerator? 2. What remains in our denominator? X plus 1. And that square root of 2x plus 96 with a plus 10 hanging out next to it. All right, at this point, we've kind of eliminated the problem, right? That x minus 2 is a factor in the numerator and denominator was a problem. So to finish this up, what we're going to do is reevaluate at x equals 2 by replacing each of the x's with 2's. So we get 2 plus 1 in that set of parentheses. Then we get the square root of 2 times 2 plus 96 with a plus 10 hanging out next to it. And let's think about what reducing this will have. Still have 2 in the numerator, but I think we end up with 3 times the square root. We've got 4 plus 96 all underneath the square root. So that's going to be the square root of 100 plus 10, bringing that along, which will further reduce to what? 2 times 3, or 2 over 3 times 10 plus 10, or 20. So 2 over 60, or best answer possible, lowest terms here, 1 over 30. All right, so that's going to be our limit as we've gone through all the steps to get there. Whenever you have a radical as part of one of these limits, think about using the conjugate of that radical to get you started on it. And that's really going to be helpful. Don't bother multiplying everything out. Just distribute the conjugates, multiply those together. And then look for that problem spot. In our case, that x minus 2. So eventually you can eliminate it and then evaluate at whatever value x is approaching. All right, good luck. Takes practice, but they're not that bad.